What is Remix? Let's dive into getting started with Remix. We'll explore the subcategory Introduction to Remix, providing an overview of Remix as a web application framework and its core philosophy. Remix is built on top of React, enhancing its capabilities for server-side rendering and improved performance. The framework focuses on data loading and routing, simplifying the process of building dynamic applications. It emphasizes progressive enhancement, ensuring optimal performance even on poor networks or with disabled JavaScript. One of Remix's key features is nested routing, enabling developers to create complex user interfaces while maintaining clean and maintainable code. It seamlessly integrates with various data fetching methods and APIs, offering flexibility for different project needs. In Remix, data loading is managed at the root level, allowing developers to fetch required data efficiently. Nested routes support breaking down larger applications into manageable components, each handling its data and UI logic independently. Remix also provides tools for form handling and robust error management, enhancing the overall user experience. To illustrate practical examples, we'll cover creating a route, handling form submissions, and adding nested routes. By leveraging Remix's features, developers can build dynamic and efficient web applications that adhere to modern web development best practices. Moving on to getting Remix installed, we'll provide step-by-step instructions on installing Remix and setting up your first project. Remix is a modern web application framework that prioritizes speed, accessibility, and user experience by leveraging modern browser capabilities. Installation is the initial step in working with Remix, requiring Node.js version 14.x or higher. Remix applications can be deployed in various environments like Express and AWS Lambda, supporting package managers such as NPM and Yarn. We'll introduce you to NPM, the Node Package Manager, and the Create Remix CLI tool for easily scaffolding new applications. The package.json file holds essential project metadata, streamlining project management. By understanding these key concepts and utilizing Remix effectively, developers can create robust web applications that deliver exceptional user experiences. Join us as we explore the world of Remix and empower developers to build cutting-edge web solutions. We delve into the world of Remix, a modern web application framework that harnesses the power of React to create accessible, fast-loading, and SEO-friendly applications. We kick off with the basics of building your first Remix application. Routes play a crucial role in Remix, defined by the folder structure in the AppRoots directory, where each file corresponds to a specific route. Loaders come into play as functions that fetch necessary data before rendering a component, enhancing server-side execution. Actions, on the other hand, manage data mutations alongside routes, while Remix's navigation component ensures seamless client-side transitions. By embarking on your Remix journey, you'll grasp the framework's unique approach to routing, data fetching, and rendering, setting the stage for more intricate applications and a deeper understanding of modern web development practices. Moving on to file-based routing, Remix simplifies route creation and management by leveraging the file system. Each file or folder within the AppRoots directory represents a route, with dynamic routing made possible through specific naming conventions. Nested routes enable complex UI structures, allowing for nested components within routes for a richer user experience. With Remix, the file structure defines routes, making routing intuitive and efficient. Nested routes and dynamic routing further enhance the flexibility and scalability of your applications, empowering you to create dynamic and engaging web experiences. We delve into the world of file-based routing with Remix, a powerful framework for handling routing in web applications. By following file conventions, developers can create a well-organized routing structure that boosts both development efficiency and application scalability. Let's kick things off by exploring the basics of data loading in Remix. Data loading involves fetching data from various sources and preparing it for rendering in web applications. Remix simplifies this process by streamlining data fetching, enabling seamless integration into the application lifecycle for enhanced user experience and performance. Key facts. Remix adopts a conventional approach to data loading, focusing on server-side handling before rendering. Loaders, asynchronous functions defined at the root level, are used to fetch data. Data can be fetched from diverse sources like REST APIs, databases, and static files, offering flexibility in data management. Next, we venture into the realm of nested routes with Remix. Nested routes allow are a hierarchical structure where child roots inherit layouts and share data from their parent roots. This setup aids in maintaining a clear and intuitive URL structure, with each nested root appending to the parent root in the URL. Whether you're diving into data loading intricacies or exploring the benefits of nested routing, understanding these concepts in the Remix framework is key to building efficient web applications. By leveraging loaders and effective data fetching strategies, developers can craft responsive and user-friendly experiences. Based on the file structure, important concepts include parent roots, which can render layout components shared by all child roots for a consistent UI. Data loading in Remix allows data to be loaded at both parent and child levels, with child roots able to receive data from their parent roots. The outlet component acts as a placeholder in the parent root for the child root's content. Understanding nested roots in Remix is crucial for well-structured web applications, facilitating better code organization and maintaining a clean UI and consistent user experience. Dynamic roots. Core concepts of Remix include subcategory routing mechanisms for creating and handling dynamic roots in Remix applications. Dynamic roots are a powerful feature allowing web applications to create flexible, user-tailored content based on URL structure. Dynamic roots enable the creation of roots that change based on variables like user IDs or product identifiers. In Remix, dynamic roots are defined using square brackets in the file structure, indicating variable portions of the root. Loaders fetch data required by dynamic roots, pre-filling content before rendering the page. Root parameters capture URL segments accessible in components, like user ID capturing the user ID parameter. Dynamic roots can be nested, allowing for complex URL structures such as user ID post ID representing a post by a specific user. Loaders fetch data dynamically using root parameters. Understanding dynamic roots in Remix is essential for scalable, user-friendly web applications, creating rich, interactive experiences that adapt to user behavior and input. Root layouts. Core concepts of Remix include subcategory routing mechanisms for managing layouts in Remix with nested roots. Root layouts create reusable UI components shared across different roots, maintaining layout consistency throughout the application. Remix allows nested routing structures where child roots inherit properties and components from parent roots. Layouts manage state and data fetching to minimize redundant API calls and optimize performance. Nested roots in Remix allow you to define roots that are children of other roots. For example, you can have a parent route, like dashboard, with a child root, such as dashboard settings, and a layout component, named dashboard layout. The purpose of this setup is to allow the child root to inherit the layout defined in dashboard layout, enabling shared components and context. Data fetching layout roots can also fetch data that can be shared with child roots. A typical layout structure includes a shared header, footer, and outlet component where child roots render. Practical examples include creating a dashboard with a sidebar and a main content area, or using a modal layout that can be conditionally rendered based on the roots. Moving on to error boundaries, a core concept of Remix, we delve into implementing error boundaries for handling errors in roots. Error boundaries only catch errors during rendering, in lifecycle methods, and in constructors of the whole tree below them. They do not catch errors for event handlers, asynchronous code like promises, set timeout, or set interval, or errors thrown in the error boundary itself. To define an error boundary, a component must implement the component did catch lifecycle method or utilize the static method get derived state from error. Error boundaries can be applied at any level of the component tree for targeted error handling. Key concepts include fallback UI, which provides a user-friendly interface when an error occurs, and logging errors, which captures error information for debugging and analytics. Error recovery techniques aim to restore the application state or navigate to a safe part of the application after an error. Lastly, we explore using loaders in Remix for data management. Loaders are functions that fetch data before a root is rendered, enabling server-side data fetching and separating data fetching logic from UI rendering. They streamline data fetching and improve application performance, helping you build efficient and robust web applications. Transitioning to handling form data, we discuss implementing forms in Remix and managing submitted data. Remix emphasizes fast page loads and optimized data fetching, making handling form data a crucial aspect of building interactive application. By using standard HTML form elements, Remix promotes accessibility and compatibility, providing built-in tooling to simplify the process. We delve into the world of Remix and explore how to handle form submissions effectively. Remix offers a special action function that seamlessly updates UI elements with nested routes. Forms in Remix are defined using standard HTML tags, and form data can be processed by server-side actions or loaders. Action functions in Remix handle post requests, accessing form data through the request object. By understanding how to manage form data, developers can create interactive user experiences that respond well to user input and efficiently manage state. Moving on to caching strategies in Remix applications, we discover the importance of caching at various levels, including browser, server, and content delivery network (CDN) caches. Common HTTP headers like cache control, etag, and last modified play a crucial role in caching, ensuring that stale data is updated or removed when necessary. Different types of caching, such as browser caching, server-side caching, and CDN caching, offer unique benefits in improving performance. By setting appropriate cache control headers, static assets like images, CSS, and JavaScript can be cached effectively in Remix applications. Implementing caching strategies, such as storing fetched data in a cache layer like Redis, can significantly enhance data fetching performance in Remix. By adopting effective caching practices, developers can build performant web applications that deliver a seamless user experience. Join us in exploring the core concepts of Remix, from handling form submissions to implementing caching strategies, to create robust and responsive applications that meet user expectations. Fetching data from APIs, where we delve into various methods, applications, and best practices to help developers optimize their applications for speed, responsiveness, and reduced operational costs. API, which stands for Application Programming Interface, allows different software applications to communicate with each other, enabling data exchange. By fetching data from APIs, web applications can display up-to-date information, interact with databases, and provide richer user experiences. APIs generally fall into two categories: REST APIs, which use standard HTTP methods, and GraphQL, which allows fetching specific data shapes in a single request. In a Remix application, integrating dynamic data efficiently is key. Understanding both client-side and server-side fetching enables developers to build high-performing applications. Moving on to using GraphQL with Remix, we explore how Remix, a modern web application framework, combined with GraphQL, a powerful query language for APIs, can enhance data fetching capabilities. GraphQL allows clients to request only the data they need, reducing overfetching and underfetching of data, providing a more efficient alternative to REST. Loaders in Remix are functions that run on the server to fetch data needed before a route is rendered and can utilize GraphQL queries to retrieve data. In GraphQL, queries fetch data, while mutations modify backend data. In Remix, these can be used within the loader for fetching and within forms for data submission. By combining Remix with GraphQL, developers can create fast, user-friendly applications that respond efficiently to user interactions. Integrating GraphQL data sources into Remix applications enhances the overall performance and responsiveness of web applications. So, whether you're looking to optimize data fetching or streamline API integration, understanding these advanced features of Remix can take your applications to the next level. In today's episode, we delve into the practical examples of using a GraphQL client like Apollo Client to streamline requests in a Remix application. By incorporating the GraphQL client within a Remix component and utilizing hooks for data retrieval, developers can enhance their workflow significantly. Furthermore, integrating GraphQL with Remix empowers developers to craft modern, efficient web applications with optimized data fetching capabilities. Leveraging Remix's loaders and action functions alongside the flexibility of GraphQL enables the creation of scalable applications that cater effectively to user needs. Moving on to our discussion on handling webhooks, we explore the advanced features of Remix, particularly focusing on API integration and setting up webhooks to manage external events. Webhooks serve as a dynamic communication tool between applications, facilitating real-time notifications based on specific events. Key facts: webhooks are user-defined HTTP callbacks triggered by events on a web platform. Typically implemented via POST requests, webhooks deliver JSON payloads to designated URLs. Validating webhooks is crucial for ensuring their authenticity, often achieved through shared secrets or signatures. Essential concepts: 1. Setting up an endpoint. Establishing an endpoint in your Remix application to receive incoming webhook requests. 2. Parsing the request body. Processing incoming webhook data accurately upon receipt. 3. Validating the webhook. Implementing validation logic to verify the legitimacy of webhook requests. 4. Acknowledging receipt. Sending an appropriate response back to the sender post-webhook processing. In conclusion, mastering the handling of webhooks in Remix involves creating dedicated endpoints, parsing content, validating requests, and sending responses. A well-executed implementation can empower applications to respond efficiently to real-time events, elevating user experience and integration capabilities. Transitioning to our next topic, building for production, we explore the advanced features of Remix concerning deployment and configuration. Understanding how to optimize a Remix app for production is essential for maximizing performance and user experience. Key facts. Remix, built on React, offers server-side rendering capabilities that enhance load times. Production builds of Remix apps prioritize performance by minimizing bundle sizes for JavaScript and CSS. Built-in routing and data fetching mechanisms in Remix enable effective data preloading, reducing loading times. Key concepts. Asset optimization. Leveraging tools like Cursor to optimize assets for improved performance. Remix utilizes tools like Babel and PostCSS to minify JavaScript and CSS files. While Remix handles many optimizations automatically, manual optimizations may still be necessary. Implement caching strategies for resources and API responses to enhance load times. Remix supports various caching methods, including HTTP caching and in-memory caching for fast data delivery. Ensure error handling and monitoring by implementing error boundaries and logging. Services like Sentry or LogRocket can help monitor errors in production for quick issue resolution. Configure environment variables to manage sensitive data like API keys and database connections for security and flexibility across different environments. Building for production with Remix focuses on delivering a high-performing and secure web application. By leveraging Remix's features and best practices, developers can enhance user experiences while maintaining efficiency in their workflows. Deploying Remix applications to platforms like Vercel, Netlify, or Heroku involves understanding deployment best practices and specifics for successful application delivery. Remix simplifies development and enhances performance by focusing on server-side rendering. It can be deployed to popular hosting platforms like Vercel, Netlify, and AWS, handling routes based on file structure. Before deployment, ensure your Remix application is built correctly with the Remix build command. Handle static assets like CSS, JavaScript, and images appropriately for the platform you are deploying to. Successfully deploying a Remix application requires understanding the deployment environment, preparing the application, and using the right commands and configurations specific to the hosting provider. Gain familiarity with these platforms and concepts to ensure your web application is accessible and performing optimally. Environment variables in Remix applications are crucial for configuration. Environment variables are essential key value pairs used to configure applications across different environments like development, testing, and production. Understanding and effectively utilizing them is crucial for configuring a Remix application. They offer vital capabilities for security, flexibility, and maintainability in web applications. Code splitting, focusing on best practices and community resources for performance optimization. Code splitting is a powerful technique that enhances web application performance by dividing code into smaller chunks. In Remix, understanding code splitting is key to efficient loading, improved performance, and a better user experience. Code splitting involves breaking JavaScript code into smaller pieces or chunks that can be loaded on demand, rather than all at once. Dynamic imports enable asynchronous loading of modules, facilitating code splitting at the module level. In Remix, each route can have its own module, allowing for segmented loading based on accessed routes. Proper chunk naming aids in debugging and cache effectiveness. Implementing code splitting in Remix enables developers to create fast, efficient applications with enhanced performance and user satisfaction. Leveraging dynamic imports, route-based code splitting, and effective chunk management are crucial strategies for optimizing the user experience. Next, we delve into image optimization, focusing on best practices for optimizing images in Remix applications. Using different image sizes for various device resolutions ensures optimal loading times. Techniques like lazy loading images within the viewport and leveraging CDNs for optimized image delivery can significantly improve loading times. Practical examples include using the Next Image component in Remix and integrating tools like Squoosh for image optimization before deployment. Lastly, we explore using service workers for offline support in Remix apps. Service Worker Scope controls the range of URLs it manages, ensuring efficient offline functionality. Stay tuned for more insights on enhancing performance through Service Worker implementation. We delve into the world of service workers and their pivotal role in enhancing user experience by enabling applications to function offline. These powerful tools not only keep users informed through push notifications but also provide a native-like experience on the web, making them a core feature of progressive web applications, PWAs. Moving on to our discussion on official documentation, we explore the importance of learning from the official Remix documentation. Mastering this framework is essential for developers as it offers foundational knowledge, continual updates, and the skills needed to build robust and modern web applications. Next, we shift our focus to community forums, where active participation can lead to a deeper understanding of the Remix framework. By engaging in discussions and following forum etiquette, learners can enhance their knowledge, collaborate with others, and solve real-world problems effectively. Lastly, we explore tutorials and examples as essential resources for learning Remix. These resources provide structured guidance, hands-on experience, and practical applications to help users grasp core concepts and functionalities of the framework. With Remix's emphasis on efficiency and performance, these tutorials and examples play a crucial role in empowering developers to create fast and user-friendly web applications. Join us as we uncover the best practices, community resources, and learning opportunities within the world of Remix, guiding you towards mastering this innovative web application framework. Important concepts. Data loading. Remix enables developers to load data on the server side, leading to faster initial page loads and improved SEO. For instance, using a loader function to fetch blog post data before rendering the page. Nested routes. Remix features nested routing, allowing for hierarchical page structures that simplify the management of complex UIs. For example, defining routes like users and user's user ID to display user lists and individual user details. Actions. In Remix, actions manage form submissions and other mutations, facilitating data modifications within the application. An illustration is using action functions to handle user registration when a form is submitted. Meta tags and SEO. Remix supports dynamically setting meta tags for each route, enhancing the application's SEO capabilities. For instance, setting a unique title and description for each blog post page. Practical examples. Setting up a new Remix project. Building a new route in a Remix application. Using a loader to fetch data from an API. Conclusion. Effectively utilizing tutorials and examples can significantly accelerate developers' learning curve with the Remix framework. By exploring the concepts provided and engaging with practical examples, learners can efficiently build robust web applications.